Two, one. Alright, hello guys, welcome back to another video. Today we're going to be learning about vectors, topic 4. Last video I taught you how to have a proper workout routine, but today I'm going to teach you something different. So as usual, don't forget to like the video, comment on the video, and subscribe to my channel. Thank you very much. Alright, so the basics on vectors, you gotta learn a little bit of vocab before we can dive into problem solving and so on. So a vector is a quantity that has magnitude and direction. We can see on this little visual that the direction is which way it's going, and the magnitude is, well, the size of the vector. We can write a vector two different ways. One in column vector form, and the other in unit vector form, using variables here, as you can see. Unit vector, well, that is basically just having a magnitude of one, the size of one. You'll be learning how to find the magnitude of a vector a little shortly. And well, a vector can be two-dimensional or three-dimensional. You can see by this illustration that the I and the J correspond with the X and Y axis respectively. We can also have a K value that is with the Z axis, which makes it third dimensional. I have a little joke right here. I don't always make vector jokes, but when I do, I JK, Alright. We have a couple key equations you must know. You have to know this or you can't carry on. So first of all, as I mentioned previously, the magnitude of a vector helps find the size or the length of the vector. And here basically, all you just want to do is substitute in the values that you have in your column vector form or your unit vector form. So v1 corresponds with v1 here. Essentially all you're doing is squaring all the values of the vector, and you're square rooting it all once you add it all up. That's how you find the magnitude or the size. Next up, we have the scalar product. Essentially what that does is finds the change in size. So different size, but same direction. You can find that two different ways. We're going to be focusing on here, scalar product. We're going to call it the dot product. What you need here is two different vectors, and you multiply the corresponding values. So the K value, you multiply those two, you add it to the I values, multiply together, and then you add those to the K values, multiply together. When you add them all up, you get your scalar product. Secondly, we have the angle between two vectors. It's self-explanatory, it helps you find the angle. So on top here, we have to remember with this, it might look similar, but it's two different operations. The numerator, you use the scalar products that you found. That's for the numerator. All you do is find the scalar product. You don't multiply two different values. The denominator, you multiply the magnitude of both of the vectors. After that, you do inverse cosine. You multiply that on both sides so that you can isolate the angle and, well, find the angle. And lastly, we have the vector equation of line. The first value is the position vector. This little sign here. This is the scalar multiple, what you're multiplying the position vector by, which is the new one. Okay. Also, we need to learn about perpendicular vectors. It's key to know that their dot product will always be equal to 0. And, well, if two vectors are perpendicular, the angle will always be 90 degrees. Using those two pieces of information, it's easy to break down. Let's say that your numerator, the dot product, is 0, right? And let's just give a random value here. Let's just say 10. So you have 0 over 10, and when you do the inverse cosine, you multiply the inverse cosine by 0 over anything, you're going to get 90. And, well, as long as you're in degree mode, you'll get 90 degrees. So the angle will always be 90 degrees. Fairly simple to understand. It's for any set of perpendicular vectors. That's why no matter what, it's always going to happen. So in example 1, we want to find the unit vector of vector A. We have working here a little bit. So essentially, first you want to find the magnitude of the vector, and we substitute in, we square every value, add them all up, and you get the square root of 38. That's the magnitude. What you want to do there then is you put every single value of the vector A over the square root of 38, the magnitude, right? And that's basically it. That's unit vector. In order to verify, we'll find the magnitude again, because the unit vector has to have a magnitude of 1, right? So here we plug it in. 2 squared is 4, and when you square root, you get the number itself. So I did that for every single one, and when you add up all of them, you get 38 over 38. And well, that's 1. The square root of 1 is 1, right? Again, okay. Example 2. We're going to determine if vectors A and B are perpendicular. We have to look at the vocabulary, the IB term used, the command term used. And if we look at that sheet that Mr. Che gave us in the beginning of the year, what a great man. You're going to get determine means to obtain the only possible answer. So it's basically a clear cut. Yes or no. Yes, it's perpendicular. No, it's not perpendicular. So I have the vectors here. And, we find the dot product. We just multiply the first set of values together, the second with the second, and the third with the third. And you add them all up. You gotta learn your order of operations. When you get that, you get 0. And like I said earlier, when a set of perpendicular vectors, you find their dot product and it's equal to 0, you can automatically assume that they're perpendicular. And yep, I have the equation written up. If you even feel doubtful, you can always just plug it in, just to be sure. It's always better to be safe than sorry, right? So yeah. So for the first IB question, I'm gonna ask you to find the angle between the vectors D and R, given that D equals 3i plus 4j and R equals 5i minus 12j. I want you to give your answer to the nearest tenth of a degree, and you can use a calculator since it's paper 2. 5 marks in the question. If you want to pause the video now, I'll let you do that. Alright guys, so I will have the answers posted right now. If you want to pause the video and look at the working, just want to let you know, you gotta know the command term is find, which, and again, the command term sheet that Mr. Che gave us says work should be shown, but may not be required. Here, it most likely, you won't need a calculator, but again, if you want to make sure, you can go ahead. First, in order to find the angle, you have to find the dot product, which I do here for the numerator, and the denominator you find the magnitudes of each one. Then you plug them into the equation. You simplify the square roots, multiply them together, and you get 65. Then when you do inverse cosine times this fraction, you get the angle of 120.51 degrees. That's your angle. Time for question number 2. So for IB question 2, question is, we have 2 questions. We're going to let vector AB equal 3i minus 2j plus 6k, and vector AC equal negative 2i plus 3j plus 2k. You're going to have 2 problems here. Total 6 marks. No calculator should be required. I'll let you pause the video now. Alright guys, so I'm going to show the answer in the work now. So for the first problem, uh, again, we see the command term find work should be shown, and again the unit vector we stated before. You have to find the magnitude of said vector, and here it came out to be perfect 7. You can always leave it in the square root symbol, but we can always after that we put the 7 as a denominator under each value in the corresponding vector. Verification, well, you can go ahead and verify if you'd like, but it's right. And for the second problem, it says show. If we look at the math command terms, show that, you have to calculate the required results. So with that in mind, what we do is we find the dot products, and we again substitute the corresponding values into each one of the variables. Simplify further down, and we get the answer 0, which shows that they are perpendicular. With the word show, you have to show it. It's gonna be perpendicular. So with that in mind, you have to get 0, or else you're not doing it right. So yeah. Thanks for watching. If you want to watch previous videos, I talked about imaginary numbers about a year ago, 2 years ago to be exact. Don't forget to join the notification squad. Again, subscribe, and thank you for watching this video. Have a nice day.